Hello and a good day to you. I am Justin Zheng,
I am Zheng.
and we are currently enrolled in the RIS program. We are going to present our assignment in this video. We were recently assigned to an exciting project at the well-known Johor, Malaysia-based food processing manufacturing facility, Sri Muda Go Sendram Berhad. We are hired as an land engineer, and our job is to design and implement local area networks for the company's manufacturing lines and departments spread across several buildings. The goal of this assignment is to build a solid network infrastructure that can support future expansion and is adapted to the unique requirements of each department. We are responsible for creating a thorough addressing system based on a thorough grasp of the organizational layout, which includes the division of departments among several buildings and the anticipated number of hosts in each region. This plan should guarantee smooth communication across departments and production lines, taking into account scalability to handle an anticipated 20% rise in network demand throughout the board. Furthermore, it is our responsibility to configure switches and routers, which are intermediate network equipment to enable effective data transfer throughout the network. Our goal is to build a strong network topology that satisfies the operational needs of the business and conforms to industry best practices by carefully allocating IP addresses and figuring out where to put network equipment. We will keep track of the design, implementation, and testing stages of this assignment to make sure the network infrastructure satisfies. We choose to use VRSM to design the address. VRSM is the ideal choice for this scenario due to its flexibility in allocating IP addresses, especially when dealing with networks of varying size. The number of hosts needed for this assignment varies depending on the department and production line. It might be as low as 20 or as high as 200. By implementing VSM, we can maximize address utilization and reduce IP address waste by subnetting the bigger networks into smaller, more suitable subnets. Better scalability and resource allocation are made possible as a result, meeting the 20% growth criterion in each area without consuming unnecessary IP address. This is how we use VSM to design the network. Firstly, identifying network segments. Secondly, determining subnet size. Thirdly, efficient address allocation. Fourthly, routing and interconnectivity. And fifthly, implementation and testing. We can build the network with highly efficient and scalable network infrastructure. We choose to use the class B address to design the address. And this is the subnet table that how we design the address. The manufacturing department, marketing department, and so on, which including the increment of 20%, and the prefix network address all is calculated in this subnet address. And going down is the addressing table. Okay, addressing table, it shows that the router, this table shows the router interface, IP address, and subnet mask, which is calculated at the top. And the next table is to show the switch allocate to all the departments. Switch 1, switch 2, and so on. Each department got one switch and total got 15 departments. And the IP address and subnet mask is also calculated at the top. And this and the PC, this is the PC table, PC device table, and also got the IP address, subnet mask, and default gateway that we calculate just now on the top of the table, subnetting table. And PC total got 45 PC. And going down, now we will go to network topology. In this network topology shows that the network design for the company. It consists of 4 buildings, which is building A, building B, building C, and building D. And it consists of 4 routers for each buildings and 15 switches and also 45 PCs for each departments and production lines. There are 3 crossover cables to connect between routers where the distance is below 100 meters. and 2 fiber optic cables to connect between routers where the distance is more than 100 meters. There are few straight-through cables to connect between switch to router and PC to switch. And now let's see the building A topology. This is building A. Building A got 3 levels. At the second floor, it is the management department, and first floor is administration department and finance department. At the ground floor, IT department, marketing department, and also logistic department. And the total router is 1 router and 6 switches and also 18 PCs. This is building B. Building B got 2 levels, first floor and second floor. First floor is engineering, research and development ERD. Ground floor is products development NPD and quality department, and total router is 1 router, 3 switches and 9 PCs. And now this is building C. Building C is for the production line 3, production line 4 and production line 5. It consists of only 1 levels and got 1 router, 3 switches and also 9 PCs. And the last building is building D. Consists of 2 floors. First floor is manufacturing department, and the ground floor is production line 1 and production line 2. Total of the router is 1 router and 3 switches and also 9 PCs. Now I will pass it to Zheng to make the further explanation.
In network configuration, we set a password and a secret password for all router and switch. We set the password is Cisco 2024 and the secret password is class 2024. And then we also assign all the IP address, subnet mask, default gateway according to the addressing table for all end devices. In Cisco packet tracer, we have 4 buildings: building A, building B, building C, and building D. And each building have a different department, and we install 1 switch, 3 end device for each department. We use straight-through cable to connect the end device, switch, and router, and use the crossover cable to connect router to router, and use fiber optic to connect router to router. We use fiber optic to connect router building A router and building C router is because the distance is further, so we use fiber optic to connect. Okay, let's do the ping connectivity desktop. We'll do the PC1 to building A first floor administration department. Okay, let's do the first thing. Ping 172.163.6.3. That's one. And then waiting. Yeah, so it is successful. You can ping one more time to check it. Yeah, it is successful to ping department building A management department to ping to administration department PC4. This zero loss. Again, we try to ping to building A to building B. Building A PC1 to building B PC19. Try to ping 1, 2, 3. This is 4.3. Okay, try to ping one more time. Yeah, and then it is successful and 0 losses. Okay, we try to ping more to building D PC27. Ping 1, 2, 3. Okay, ping one more time. And then it is successful and 0 loss. Try to ping last one. Try to ping to building C PC27 the 8. Okay, ping one more time. And then it's also successful and 0 loss. Okay. Okay, that's all. Thank you.